Hey everyone, Wes here. Welcome back to the Gang of Four Design Pattern series. If you're just joining me for the first time in this series, welcome. I am covering every design pattern that is explored in the famous Gang of Four Design Patterns book in C#. In this video, we're going to pick up where we left off among the creational patterns and take a look at the builder pattern. So if you're not already familiar with the factory method pattern, I would recommend going back and checking out the first video in this series to get a good sense for some of the benefits of the factory method pattern and some of the particular use cases for that pattern, as the factory method is really probably the fundamental design pattern in terms of creational design patterns. The builder pattern is a bit more complex, and the trade-off that we get with that complexity is that we have a really good pattern for cases when we need to construct complex objects, and it might be beneficial to do that in a step-by-step fashion. So in this video, we're going to take a look at two approaches to the builder pattern. One, the traditional Gang of Four approach, and another, a sort of fluent builder pattern approach, one that I found useful in practice quite often when trying to create complex objects in unit testing scenarios. So I want to demonstrate both of those approaches. As usual, all of the code for this is in the description below, and if you get anything out of this series, I'd really appreciate it if you like the video, and be sure to subscribe to find out when the next design pattern video is released. So with that, let's go ahead and dive in and take a look at when and why we might use the builder pattern in C#. Alright, so let's dive in and take a look at our second design pattern of this series. This will be our builder pattern. If you aren't already pretty familiar with the factory method pattern, I would recommend checking that out as well, as that's really probably, I would say, the fundamental creational design pattern that's really worth knowing. And some of the other creational patterns that we'll look at, including the builder pattern, are for generally more specific types of use cases. So it's going to have all of the same benefits that the factory method pattern has, but it'll be a bit more complex, and the complexity there will be due to the specific type of use case in which we might want to actually work with this pattern. And that's generally going to be the case for the other creational patterns as well. So be sure to have at least a pretty good understanding of some of the benefits of the factory method pattern, and that'll help you make a decision about whether or not something like the builder pattern is also applicable for your particular use case. So let's take a look at what the definition of a builder pattern is. So it's a creational pattern, like the factory method pattern, that separates the flexible construction of complex objects from their representation. So this already sounds pretty similar to the factory method in that it's a creational pattern, and we have some separation of concerns here between the construction or creation of some object, and in this case its representation, or perhaps where that object is used. One of the key points of the builder pattern, and where it really starts to become useful, is when we need to work with the construction of complex objects. So if you've ever worked with an object that required a lot of state at the time of its creation, and you've worked with, say, some constructor that has a bunch of parameters to set state on that object, then you know generally how sort of messy and unwieldy those types of objects can be to construct. Generally, it's kind of a smell to just continue to add parameters to a method, including a constructor, because it starts to get hard to discern, like, say, even just like the order of the parameters that go into the constructor. Generally, we want some way to be able to set state without worrying about sort of front-loading a whole bunch of state through a constructor for creating a new object. And we'll take a look at how the builder pattern helps us with that particular smell. But it's also the case that as object construction gets kind of complex, we want some way to be able to reason about it without trying to understand every piece of state that goes into that object up front. So the builder pattern will help us with that. And so by separating the code here that handles the construction of a complex object in different ways, And in a step-by-step fashion, we can make complex object construction more extensible. So as you might imagine, when object construction gets really complex, because we have some complex object to build, we know the number of different states that that object could take could explode, and there may be certain states which are useful for us over and over again, in which we want to just be able to quickly construct them in that state. And so maybe we have different ways of creating different instances of a type that are loaded with different configurations. We can take a look at how we might use the builder pattern in that regard as well. And then we'll also look at how we can do this in a step-by-step fashion, again, so that maybe we don't have to just load in all of the state all at once in a constructor, and instead do this in a step-by-step way. We're also going to look at a slight variation that's not explicitly part of the Gang of Four patterns called the fluent builder, and so I have a second example to that as well, which provides us with a fluent step-by-step syntax, which can be really useful in a lot of cases, particularly for things like creating fake objects to work with in unit tests, and in plenty of other scenarios. So let's take a look at the sort of standard UML diagram for a builder pattern. This is in particular an adaptation of the Gang of Four pattern for the builder pattern, diagram for the pattern rather. So what we have here is a director instance which is going to have an object which implements iBuild's products in this case. So this particular syntax here is what the Gang of Four would call an aggregate, and today in our sort of modern lingo we would generally just call this composition. The Gang of Four makes a distinction between two types of composition. It calls this particular relationship an aggregation. There's another type of composition they call acquaintance. The difference there is really what they call an aggregate and what I would call composition is that the director has an instance of something in this case, and that it is the lifetime scope of the instance that it has is tied to the lifetime scope of the object that has it. So when director goes out of scope and is destructed, for instance, then concrete builder, in this case, whatever is implementing this interface, goes with it. So this is just a standard director has something that implements this interface. Whereas the acquaintance concept is a looser relationship, in which case some object might only, as they say, know about another type of object and can in some other way indirectly interact with it, but the two lifetime scopes of those objects are independent. In this case, we just have standard composition where a director has something that implements iBuild's products here. Okay, so that's a long-winded explanation, but since we're kind of sticking to the Gang of Four book, I wanted to mention their terminology for things. So we have this director object. It has something that implements iBuild's products, and that interface is implemented by a concrete builder, which ultimately instantiates our product. So our product is the complex thing that we want to be able to build, but we don't want our director, or wherever our director is used in the client, to have to say new product with a whole bunch of parameters in the constructor and use this big unwieldy object that would get newed up in a particular place, either in the director or at some level even higher. And so different implementations of iBuild's products will produce different configurations of a particular product. And the director can call construct to invoke the concrete builder in different ways to actually make that happen. So the concrete builder is going to say, like, step-by-step build part A of product, build part B of product, and then ultimately something like create or make product, and it will sort of materialize that new instance of product for us to use in the director. So it's important here also to note that the director works with interfaces, so that any number of different concrete implementations of iBuild's products could be used to produce different outcomes, different types of, or different configurations of a product. So now we'll look at the diagram in a real-world use case as it's used in the code. So we're going to be dealing with a purchase order builder, and I chose purchase orders because generally they're very common, relatively complex objects that could potentially hold a lot of state, and the state of which is often known at the time that the object is needed, and so it seems like a relevant use case for a builder pattern. So our director in this case is actually our purchase order processor. And this class can do stuff like generate weekly purchase orders. It can save a purchase order to the database. Maybe it can send an email to a vendor. So it has this relationship where it has a implementation of something that builds purchase orders, which is our iBuild purchase orders. And this can be implemented in our case by either a bakery PO builder or a coffee PO builder. And so we can imagine that the bakery PO builder builds a purchase order by following all of the conventions that our bakery suppliers require of us. So maybe they have a particular type of PO ID that they want to see on their end. They certainly have different line items that might need to get constructed on their standard weekly PO than our coffee vendors. And so we have sort of implemented the single responsibility principle here, which is to say that any given class should have one reason to change. And our bakery PO builder changes based on what our bakery vendors require of the POs that we generate. And likewise, our coffee PO builder would change only for the POs that we build for our coffee vendors. However, both of these implement the same interface, and so we could very easily generate new concrete implementations of iBuild purchase orders, say for some other type of vendor we might have that we might sell things at our cafe or our bakery, so like a t-shirt vendor or something like that. And nonetheless, the director in this case could still use the same method to generate a weekly purchase order and save that purchase order to the database. And since it's working with interfaces in general, all we would need to do is to create a t-shirt purchase order builder that would implement the same interface and produce another purchase order object which is just configured differently for that particular use case. Okay, so I think that's enough diagramming. Now we should dive right into some code and take a look at the implementation of this. And we'll take a look at actually two implementations. One, which is this sort of gang of four design pattern with the director. And then we'll also look at another variation that I found really useful in practice called the Fluent PO builder, or the Fluent builder. So let's take a look. Okay, so here we are in the solution. And if you want to take a look along with me here, the bakery purchase order system, which is in our example programs, Creational examples namespace, has a console app in it, and so that's what we'll be looking at here first, just to kind of see how things work. There's some comments here. Feel free to check them out if you're interested in the details, but basically I'm just going to cover this in more of a natural way of speaking about it. So we're going to look at a first approach here, which is what we just reviewed, a typical sort of gang of four builder pattern in which we're going to use a director and then some particular builder. So the main method here, this is sort of the root of our application. It's the entry point, and so in terms of dependencies, this is where they're going to be created. In dependency injection terms, this would be like our composition root or our container. So we're going to have a logger that's used throughout the app and a database that's used throughout the app, and that's going to get injected here manually, if you will, just through constructors to the various objects. So these are our third-party dependencies. We have some concrete builders here, as we saw. We're going to have a bakery PO builder and a coffee PO builder, and then a director class, which is our purchase order processor. All the PO processor takes when instantiated are our third-party dependencies, so our logger and our database. But then the PO processor has on it a method, generate weekly purchase order, that takes as a single argument anything that implements iBuild purchase orders. So just to step into one of these methods really quickly, our bakery PO builder implements iBuild purchase orders. The only thing that we need on anything that implements iBuild purchase orders are methods for the various steps of creating some purchase order object. So as you can see, we can do things like set the ID, set the company, the address, the date, the supplier, and the items. And these are all void methods, which are actually just changing the state of some purchase order object. So if we take a look at the bakery purchase order, what we have is we have some backing fields here for the state that's going to be contained by the purchase order ultimately. And each time we call one of these methods, it is modifying or mutating these backing fields, which are private to the PO builder itself. So we can set all of our state using this builder class, and then we have this very important method which ultimately calls each of those methods and returns that purchase order instance. So this is sort of the helper method here. If we wanted to think about this a little bit differently, we could of course call these methods from some other place and then create a method here which sets the backing fields later instead of encapsulating everything here in one method. But for the simple purposes of this example, we build a purchase order. What this does is it actually calls these methods for us and then returns us a PO. And that's really all there is to the purchase order builder itself here. We'll talk about what this static implicit operator is a bit later, but that'll become relevant with the Fluent builder. So as far as sort of Gang of 4 approach is concerned, this is an implementation of iBuild's purchase orders. If we take a look at another implementation, we can head back here, we can see our coffee purchase order builder. And some of the things that it might do differently is it might set the ID differently here, for instance. So here we have coffee underscore date with this syntax, whereas in the case of the bakery purchase order, we have a slightly different syntax with bakery underscore. And so the coffee builder could do any number of things differently, and in fact it does. It's still an implementation of iBuild's purchase orders, but it sets its backing fields a bit differently according to the particular weekly POs that we generate for coffee. Likewise, it has a build purchase order method which returns that fully constructed purchase order. Okay, so we have these two builders. We have our PO processor, which is our director class, and we call generate weekly purchase order once for each of the particular builder instances that we've created or implementations. So let's take a look at what happens when we call that. This takes in anything that implements iBuild's purchase orders. So through this approach using dynamic polymorphism, we can of course make this our code extensible, because we could implement iBuild's purchase orders into the future in many different ways without actually changing what the behavior of generate weekly purchase order is, or changing the code, because its behavior is just to generate a weekly purchase order for some type of thing that implements this interface. So it calls PO builder dot build purchase order, and we know that that's going to return a purchase order. In our case, we can implement that as either a PO for a bakery or a PO for the coffee. And then we call print purchase order and we save it to the database. So our director here has a little bit of additional responsibility, just to show you that this responsibility exists separately from the construction of and use of these objects. We can save this purchase order to a database using a dependency that was injected into the PO processor. We can log some things out here, and then ultimately we can print the purchase order, and everything is just parameterized here with the order ID and the company name and all of the state, that complex state that's on our purchase order object. Okay, so what happens when we do this is when we call this generate weekly purchase order, as we saw, we build it using the particular implementation of iBuild's purchase orders, and we print it and then we save it to the database. So the benefits that we see here, just to recap, are that the director class here can take in anything that implements iBuild's purchase orders. In our case, we've created implementations for bakery POs and coffee POs, but into the future, as we have new suppliers that require some weekly POs to be generated, we could add those classes to our solution and then call the same business logic that generates weekly purchase orders for any implementation for those new suppliers. Furthermore, the purchase orders, since they're fairly complex objects themselves, we can encapsulate all of that logic that's related to creating these POs and put in individual methods the things that change state on such an object into some builder class here and keep things separate. So in the event that POs even grow in complexity over time and have new fields that we need to set on them for whatever reason, or perhaps fields get removed, rather than look through everywhere where a constructor is used to build that object, we would come to the builders themselves and actually add or remove methods here, which keeps code a lot cleaner than trying to find every place a constructor was used and modifying it there. We have one place where the logic lives for creating these purchase orders, and then in fact we would still be able to call build purchase order and it would produce whatever the current shape and state of those purchase order objects is in any case. Okay, so we have one more approach here, and I wanted to bring this one up because it's actually something that I've used a lot when building automation test framework code. And this is called the Fluent Builder approach, and it's not explicitly part of what we just looked at, although the general concept of creating an object step by step is still the same. Here we don't necessarily have a director class, but instead what we want is some way to use a fluent syntax which sort of reads very naturally for creating an object in step-by-step fashion. And so for that I've created another interface called iFluent Purchase Order Builder, and this is pretty interesting and a little bit tricky if you're looking at it for the first time, I would say. But once you sort of get the hang of it and see what's happening here, I think it's pretty clever, and it can be useful for use cases for things like, I would say, creating fake objects for unit testing, for instance. So this interface defines the same types of methods that we saw on the interfaces for the other builders, except this is actually returning the same interface itself. So when we call with ID, we're actually going to return an iFluent purchase order builder, something that implements that interface. So rather than be a void method that changes some state on some object, this is going to actually return an instance of something that implements this interface itself, and then ultimately still builds a purchase order for us. So let's see how this is actually used. So this gets implemented in a concrete class, Fluent Purchase Order Builder. It still has the same backing fields that we saw in our other purchase order builders, except rather than have those void methods as was mentioned, we're actually going to return this. So we're returning the same instance of the thing that we're working with here. So we set the ID based on some parameter that we pass the method for with ID, and then we just return that same object. This is actually going to let us do method chaining against any particular instance of a Fluent Purchase Order Builder. So we're going to be able to set the ID, then we can chain in like the request date, the address, the company, the line items, and then ultimately we still build a purchase order if we like, but this is where this sort of fancy implicit operator method comes into play. And what this is it's a way to tell the compiler that when I have an instance of a Fluent Purchase Order Builder, we can treat this as a purchase order. I just need to tell you explicitly how to convert it. And by telling it how to convert it here, then the compiler can implicitly treat any Fluent Purchase Order Builder as a purchase order. So what this allows us to do is to use the builder, and then without explicitly ourselves calling build purchase order, we can just use that builder instance as a purchase order itself. So we just return builder.build purchase order. That's going to return a new purchase order instance. This new curly brace syntax is using target type. So this is a C#9 feature, I believe. But what we're going to do is return a new instance of this purchase order, and then we use all those backing fields that we've been setting as the values on the purchase order instance itself. Okay, so what would this look like in use? Well, this is part 2, the second approach. This is our custom builder using a Fluent syntax. And so the director is not in play here. We're just going to use the Fluent builder directly in our client. And so we can see that we're going to new up a Fluent purchase order builder instance. This is that builder that we were just looking at. We have some line items that we want to use and a new supplier that we want to use. And then we can chain together those methods on that Fluent purchase order builder to just say with ID, at address for a company, because each time we call one of these methods, it's actually just returning the object, the custom order that we're working with. And so we're modifying the state each time we call one of these methods, and we're returning it back to the caller here. We can continue chaining for all of the various properties. So this gives us or backing fields in this case. This gives us a nice Fluent syntax to say things like an order with an ID at an address for a company, from a supplier, etc. And then we can actually just use this as if it were a purchase order rather than a Fluent purchase order builder, because of the fact that we have this implicit operator which does that conversion for us. The compiler sees this, and then anywhere we accept a purchase order instance, the compiler knows how to do that conversion because we've told it in that implicit operator method. So then we can do the same types of things we were doing in our director class earlier. We can save it to a database. We can print the purchase order. So with that, let's go ahead and run the program, and we can see it in action. Okay, so here we are in the example program /creational examples /bakery purchase order system, and we can just run .NET run here. So we're going to see both examples run here. We have a PO for our bakery. We'll see it connect to the database using that database dependency. We'll generate the purchase order for the coffee, and then our custom purchase order using the Fluent builder will get executed in the third sort of example here. So with that, I hope this helps you understand the builder pattern a little bit better than perhaps you did before. One of the things I want to mention here very quickly is a trade-off. As you noticed, especially if you've taken a look at the factory method example, the builder pattern introduces a bit more complexity. We have more objects to work with. Their orchestration is a little bit more involved than just simply setting up a factory method. And so the trade-off that we have here is with the introduction of that complexity, which will need to be maintained and understood by anyone working on it, we now have the benefit of being able to relatively easily creating complex objects that whose state needs to be set in perhaps many different ways. And so by being able to work with the construction of those objects at a high level of abstraction, we have perhaps reduced complexity and readability of the higher level code, but the implementation details here are a bit more complex than just a regular factory method. So something to keep in mind, something that the authors mention is that design patterns like the builder pattern often evolve out of simple use cases where a factory method is used initially. And so if you find yourself in a situation where you're saying, hey, I suddenly realize that I need to create this complex object, I have this huge constructor, and every time I need a new instance of something, I'm filling in 6 fields in this constructor or more, maybe it's time to start thinking about abstracting that away into these objects that explicitly do the building of that object that you want to use in a step-by-step way, and then maybe even thinking about using this director to encapsulate all of that logic in one place that can be used by a client. So that's the builder pattern in a nutshell. 2 variations, one strictly speaking the Gang of 4 implementation, and then a look at this Fluent builder pattern. Thanks for watching, and I'll see you in the next design patterns video.